All right, this is a continuation of section 3.2. This time we're going to graph linear equations where the constant is 0. So that's going to make it just a little bit different. So let's see what happens here. All right, so if I plug in x equals 0 to find my y-intercept, plug in x equals 0. So I have 4 times 0 minus 2y is equal to 0. I get negative 2y is equal to 0. Divide by negative 2. Be really careful because 0 divided by anything is 0. It's not 1. It's not negative 2. 0, 0. Now, I want you to pay particular attention right here, okay? Can you guess what's going to happen if I plug in y equals 0? Let's try it. 4x minus 2 times 0 is equal to 0. Divide by 4, and sure enough, I get the point 0, 0 again. So this is my x-intercept. This is my y-intercept, and it's the same point. But remember, I said you have to have 3 points. In order to be able to graph, I want you to do 3 points, and this only gives us 1 point. Normally, I get 2, okay? But this only gives us 1. So what we're going to have to do is actually, instead of finding one other number to plug in, we're actually going to have to plug in 2 numbers. So in this case, we're going to let x equals 2, and we're going to let y equals 2. Okay? So plug in x equals 2. 4 times 2 minus 2y. And we get 8 minus 2y is equal to 0. And divide by negative 2. And we get y is equal to 4. So we have the point 2, 4. Now we're going to plug in y equals 2. And reminder, you're not going to know ahead of time what number to plug in to avoid fractions. So you're just going to have to plug in a random number and graph it with a fraction. And divide by 4. You get x equals 1. There you go. And so we are going to plot these points right there. 1, 2, and connect them. Notice it goes through the origin. Anytime it equals 0 like this, you're going to end up going through the origin. So that's basically what I just said. So if you have it equal to 0, you're going to go through the origin. All right. Notice this equation right here. This is a linear equation. The graph will be a line. It is not a number. It is not a point. It is a line. But it does not have the variable x. So I want to remind you that if I were to add 0 to both sides, I haven't changed the equation, correct? 0 plus y is equal to negative 5. I haven't changed the equation at all. If I multiply y by multiply 0 by any number at all, I still haven't changed the equation. So what I'm going to do is I'm going to multiply 0 by x. Notice 0 times x is 0, which we don't have to write. Here's why I do this, okay? First of all, to emphasize that it is actually, in fact, a linear equation with 2 variables. You just don't see the other one. And some students struggle, like if I ask you to plug in x equals 0, they're like, where do I plug it in? Well, you plug it in for x. So you have 0 times 0 plus y is equal to -5, or y is equal to -5. If I plug in 2, I have 0 times 2 plus y equals -5. Notice I have 0. Again, y is equal to -5. Again, if I plug in -3, I get y is equal to -5. For any value of x, my y will always be -5. For any value of x, my y will always be -5. So if my x is 0, I'm going to have a y value of -5. If my x is 2, -5. -3, -5. Notice my graph is what's called a horizontal line. This is a horizontal line. I also want to point out, you ready? Students all the time, consistently, like I cannot tell you how many thousands of students I have taught, and they all do the same thing. They see this equation, y equals -5, and they think that the equation y equals -5, that the graph is parallel to the y-axis, but it isn't. It's perpendicular to the y-axis. One more time. Y equals -5 is perpendicular to the y-axis. Okay, something to keep in mind when we do this one, because this time I have x equals a number. So regardless of what my y is, my x is always going to be 2. This is not going to be parallel to the x-axis. It's going to be perpendicular to the x-axis. 2, 0, 2, 1, and here we have a vertical line perpendicular to the x-axis. Something to watch out for. The graph of y equal any single number is going to be a horizontal line with the y-intercept at 0b. It's not going to have an x-intercept unless it's a horizontal line at y equals 0, the x-axis. Conversely, the exact opposite, x equals a number, is going to be a vertical line with an x-intercept at that number 0, no y-intercept, unless the vertical line is the y-axis itself. All right, so in the United States, the weekly time spent online, y, in hours can be modeled by the linear equation y is equal to 0.9x plus 9.1. And this is old data. I imagine that this has changed. So pay attention when it says where x equals 0 represents the year 2000. So x equals 1 would represent the year 2001. If I said x is equal to 20, that would represent the year 2020. If I said x is equal to 50, it would represent 2050, etc. So we are going to use the graph, which is on the next slide, and we are going to approximate the weekly time spent online in 2005. X would equal 5. So for 2005, we have x is equal to 5. So x is equal to 5. And we are going to go up And my time spent is approximately 14 hours. Okay, this is different from take 5 and plug it into the equation. Okay, it may or may not be exactly 14 hours. When I say use the graph, I mean use the graph. Okay, so it could be an approximation. It could be off by a little bit. That's fine. If it says use the graph, I do not want you to take 5 and plug it into the equation. I want you to actually look at the graph and tell me what it looks like. Now, for this, we're going to use the actual equation, and then we're going to compare how close our approximation with the 14 hours is to the actual time spent using x equals 5. So y is equal to 0.96 plus 9.1, and we're going to grab our calculator. One of these days I'm going to actually remember to have that handy. 0.96. And it turns out it is not 14 hours exactly. It's actually 13.9 hours. Okay, so on this example right here, when I tell you to use the graph and you give me 13.9 hours, I'm going to mark it wrong because there's absolutely no way you can get that close by looking at the graph as an approximation. Okay, 14 would be marked correct, 13.9 would be marked incorrect. And there you go.